Some may think that maths is boring. I'm sure that you watching this might even have felt the same way. But have you ever taken a minute to think about what maths makes possible?
Think about architecture. How would the world around us look without maths? Maths is the reason you have a roof over your head. It is the basis of architecture, and the world we know today wouldn't be the same if it wasn't for maths. Architects are the people who design buildings and other structures. By both intentionally and unknowingly using maths for their job, they ensure that these buildings are safe, economical, and functional. Calculating proportions, working out rainwater catchment for calculating gutter and pipe sizes, and estimating the expanded number of people per square metre are just three examples of the many aspects of architecture that rely on maths. Without maths, residential, educational, business, and industrial buildings wouldn't exist. The city you live in wouldn't exist. The world we live in heavily relies on maths.
Nature and man-made things have more in common than meets the eye. For example, they are both based on the same mathematical ideas and concepts. Let's go to the whiteboard. Maths is the reason we and every other organism on this planet are alive today. Animals, for example, migrate mainly because of temperature. Without maths, temperature simply wouldn't exist, and animals would have no idea when to migrate. If we look at natural disasters, hurricanes have a specific spiral pattern extremely similar to that of the Fibonacci sequence, and so hurricanes need maths to be possible. Trees are also a major part of nature, as without trees, animals and billions of other organisms around the world wouldn't be able to breathe and therefore live without maths. Trees and other plants go through the process of photosynthesis, taking carbon dioxide, water, and energy and transforming it into oxygen and glucose. Without maths creating the chemicals needed for the process of photosynthesis, trees and other plants would not be able to undergo this process. Respiration works in the opposite way, happening to trees, other plants, humans, and other animals, using oxygen and producing carbon dioxide. This needs maths in the same way that the process of photosynthesis does. Maths allows us to create medicine and other life-saving tools simply because of plants and other organisms readily available in today's ecosystems.
Doctors and nurses use maths when they write prescriptions or administer medication. Medical professionals use maths when drawing up statistical graphs of epidemics or success rates of treatments. X-rays, CAT scans, pills, injections, and solutions are all integrated in the daily life of a medical practitioner, and all require maths to thrive. Biomedicine has aided in the development of new treatments for human illnesses, diseases, and disability. It allows people to explore solutions to health problems across the world. It pinpoints a problem with a patient and fixes the complication through medical intervention. Maths is shown in medicine from the writing of prescriptions to the measurement of ratios and proportions. If the patient weighs 52 kilos, how many milligrams should the patient receive in 1 hour? In order to do this, nurses must convert micrograms to milligrams. If 1 microgram equals 0.001 milligram, we can find the amount of 25 micrograms by setting up a proportion. How do they know this? Why is it that they can decipher the patient's exact needs just by their weight? The answer is maths. Maths is the basis of biomedicine, and as biomedicine saves lives and aids to curing diseases, maths makes life possible.
Maths is everywhere, from nature to architecture and even biomedicine. We need maths to survive and use it every day. Without it in the world, it wouldn't exist. This is why maths makes everything possible.